The topic of this session is numerical integration, which is a topic in the fourth module of fourth semester B.Sc complementary mathematics. In the previous sessions, we studied methods like Picard's iteration method, Euler method, modified Euler method, and Runge-Kutta method, which are used to find approximate solution of first order initial value problem. And this topic, numerical integration, which is used to find the approximate value of integral a to b f of x dx. So we have to study two methods. First one is trapezoidal rule and the second one is Simpson's rule. So the first one is trapezoidal rule. Trapezoidal rule is used to find the approximate value of integral a to b f of x dx. So we have to find the approximate value of integral a to b f of x dx using trapezoidal rule. So for this, we divide interval a b into equal subintervals. We divide interval a b into equal subintervals. For this, either we are given number of subintervals or length of subinterval, number of subintervals n or length of subinterval h. We divide AB into subintervals of equal length. For this, either we are given number of subintervals n or length of subinterval h. So the relation connecting this n and h is equal to b minus a divided by n. This is the relation connecting h and n. N is number of subintervals, h is length of the subinterval. The subintervals are x0, x1, x1, x2, etc. xn minus 1, xn. Subintervals are of equal length. x1 is equal to x0 is equal to a, x1 is equal to x0 plus h. This is a plus h. x2 is equal to x0 plus 2h, a plus 2h, etc. xn minus 1 is equal to x naught plus n minus 1 into h is a plus n minus 1 into h. xn is equal to x naught plus nh, a plus nh is equal to b. X naught is equal to a and xn is equal to b. Start with a, end with b. Now we find the value of the function at the n points of these subintervals, that is at points x0, x1, x2, etc., xn minus 1 and xn. Y naught is equal to, it is y of x naught, this is equal to f of x naught. Here y is f of x. Y1 is equal to y of x1 is equal to f of x1. Y2 is equal to y of x2 is equal to f of x2, etc. Yn minus 1 is y of xn minus 1 is equal to f of xn minus 1. Yn is equal to y of xn is equal to f of xn. We evaluate the value of the function at the n points of these subintervals x0, x1, x2, etc., xn minus 1, xn. Then by trapezoidal rule, the value of the value of the integral a to b f of x dx is t is equal to h by 2 into y naught plus 2y1 plus 2y2 plus etc. 2yn minus 1 plus yn. So this is the formula to find approximate value of integral a to b f of x dx using trapezoidal rule. T is equal to h by 2 into y naught plus 2y1 plus 2y2 plus etc. 2yn minus 1 plus yn. 1 into y naught, 1 into yn. Multiply all other terms by 2. Add them, multiply it by h by 2. Example. Use trapezoidal rule with n is equal to 4 to estimate integral 1 to 2 x square dx. Compare the estimate with the exact value of the integral. Exact value of integral. Here integral a to b f of x dx is equal to integral 1 to 2 x square dx. So here a is equal to 1, b is equal to 2, y of x is equal to f of x is equal to x square. We have given value of n is equal to 4. N is number of subintervals. We divide the interval AB, interval 1, 2 into 4 equal subintervals. N is equal to 4. Then H is equal to, then length of each subinterval. H is equal to, it is B minus A divided by N. This is equal to 2 minus 1 divided by 4. This is equal to 1 by 4 is equal to 0.25. Then x naught is equal to the left end point of the interval AB. This 1. This is the left end point of the interval, which is 1. X naught is equal to A is equal to 1. X1 is equal to x naught plus h, 1 plus 0.25. 1.25. X2 is equal to x naught plus 2h, 1 plus 2 into 0.25, 1.5. X3 is equal to x naught plus 3h, 1 plus 3 into 0.25, 1.75. X4 is equal to x naught plus 4h is equal to 1 plus 4 into 0.25, it is 2. So here x4 is equal to 2, which is equal to B, the right end point of the interval. So we stop here. When n is equal to 4, x4 is equal to 2, that is equal to B. So we start with x naught is equal to A and end with x4 is equal to 2. Here we are given n is equal to 4. Now we evaluate the value of the function at these points x0, x1, x2, x3, x4, which are endpoints of the subintervals. Y naught is equal to, it is y of x naught is equal to, it is f of x naught is equal to f of 1. F of x is x square, so f of 1 is 1 square. This is equal to 1. Y1 is equal to y of x1. It is f of x1 is 1.25. 1.25 square. F of x is x square. F of 1.25 is 1.25 square. 1.5625. Y2 is equal to y of x2. It is f of x2 is 1.5. F of x is x square. F of 1.5 is 1.5 square. 2.25. Y3 is equal to y of x3. Is f of 1.75. x3 is 1.75. 1.75 square. This is equal to 3.0625. Y4 is equal to y of x4. This f of 2, x4 is equal to 2. This is equal to 2 square. This is equal to 4. So we calculated the value of the function at the points x0, x1, x2, x3, x4, which are y0, y1, y2, y3, y4. Now, by trapezoidal rule, the approximate value of the integral 1 to 2 x square dx, approximate value of integral 1 to 2 x square dx t is equal to, it is h by 2 into y naught plus 2y1 plus 2y2 plus 2y3 plus y4. 1 into y naught, 1 into y4, all other terms multiply by 2. 2 into y1, 2 into y2, 2 into y3. Add them. This is equal to 0.25 divided by 2 into y naught is 1. 2 into y1, 1.5625. 2 into y2, 2 into 2.25. 2 into y3, 2 into 3.0625 plus y4. y4 is 4. Calculate this using a calculator. The value we get is, it is equal to 2.34375. So this is the approximate value of the integral 1 to 2 x square dx using trapezoidal rule. Now the exact value is, exact value is integral 1 to 2 x square dx is equal to, it is x cube divided by 3, the limit is from 1 to 2, it is equal to 2 cube divided by 3 minus 1 cube divided by 3. This is 8 by 3 minus 1 by 3. This is equal to 7 by 3. This is equal to 2.33. This is the exact value, and this is the approximate value by trapezoidal rule. So the difference between these two is the error. Error is equal to this is the approximate value minus the exact value. This is the error, 2.34375 minus 2.3333. So this is equal to 0.01042. This is the error obtained when we calculate the integral 1 to 2 x square dx by trapezoidal rule. Next example, find approximate value of integral 2 to 3 1 by x dx using trapezoidal rule. With h is equal to 0.125. Compare with the exact value. Here integral a to b f of x dx is equal to integral 2 to 3 1 by x dx. So a is equal to 2, b is equal to 3, f of x is equal to 1 by x. Here we are given the length of each subinterval, h is equal to 0.125. H is equal to 0.125. Now start with x naught is equal to a. start with the x naught is equal to the left end point of the interval AB 2. X naught is equal to A is equal to 2. X1 is equal to x naught plus h 2 plus 0.125 2.125. X2 is equal to x naught plus 2h 2 plus 2 into 0.125 2.25. X3 is equal to x naught plus 3h 2 plus 3 into 0.125 2.375. X4 is equal to x naught plus 4h 2 plus 4 into 0.125 this 2.5. X5 is equal to x naught plus 5h 2 plus 5 into 0.125 is 2.625. X6 is equal to x naught plus 6h 2 plus 6 into 0.125 is 2.75. X7 is x naught plus 7h 2 plus 7 into 0.125 2.875. X8 is equal to x naught plus 8h 2 plus 8 into 0.125. It is 2 plus 1 is equal to 3. X8 is equal to 3. So we reached the right end point of the interval AB 3. So we stop there. Start with the x naught is equal to A equal to 2. This is the left end point of the interval. Then find the x1, x2, etc. When we reach the right end point 3, then we stop there. So here n is equal to 8. Here number of subintervals is equal to 8. X8 is equal to 3. Now find value of the function at these points x0, x1, x2, x3, etc. x8. That is the endpoints of the subintervals. Y0 is equal to, it is y of x0. It is y of x0 is equal to f of x0 is equal to, here the function is 1 by x. It is f of 2. It is 1 by 2. This is equal to 0.5. Here f of x is 1 by x. X0 is equal to 2. Y1 is equal to, it is y of x1. It is f of 2.125. Y of x is f of x1 is 2.125. F of x is 1 by x. 1 by 2.125. So the value is 0.4706. Y2 is y of x2. It is f of x2 is 2.25. 1 by 2.25. This is equal to 0.4444. Y3 is equal to y of x3. F of 2.375. It is f of x is 1 by x. 1 by 2.375. This is equal to 0.421. 0.4211. Y4 is y of x4. It is f of x4 is 2.5. It is 1 by 2.5. This is equal 1 by 2.5 is 0.4. y5 is equal to y of x5 is equal to f of 2.625. This 1 by 2.625. This is equal to 0.381. 0.381. y6 is equal to y of x6 f of 2.75. 1 by 2.75 is equal to 0.3636. y7 is equal to y of x7. It is f of 2.875. 1 by 2.875. It is 0.3478. y8 is equal to y of x8. f of x8 is equal to 3. It is 1 by 3. It is 0.3333. So we have found the values of the function at x0, x1, x2, etc., x8. That is, we found the values y0, y1, y2, etc., y8. Now, by trapezoidal rule, the approximate value of the integral 2 to 3 1 by x dx, t is equal to t is approximate value of integral 2 to 3 1 by x dx. It is h by 2 into y0 plus 2y1 plus 2y2 plus 2y3 plus etc. plus 2y7 plus y8. y0 y8 ഒഴികെ ബാക്കിയുള്ള എല്ലാ ടേമിനും 2 കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്യാം. y0 is the first term, y8 is the last term. ബാക്കി ടേമുകളെ 2 കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്യാം. So this is equal to h is 0.125. 0.125 divided by 2 into. We have value of y0 is 0.5. Value of y1 is 2 into 0.4706. 2y2. 2 into 0.4444 plus 2y3. 2 into 0.4211 plus 2 into y4 0.4. 2 into y5 0.381. 2 into y6 0.3636 plus 2 into y7 0.3478 plus y8 0.3333. Calculate the value of this using a calculator. We obtain the value is equal to 0.4056. This is approximate value of integral 2 to 3 1 by x dx using trapezoidal rule. Now exact value is integral 2 to 3 1 by x dx is equal to ln x. The limit is from 2 to 3. It is ln 3 minus ln 2. So the value we obtained is 4055. So here the error is the estimated value minus exact value. It is 0.4056 minus 0.4055. It is 0.0001. This is the error occurred. The example, first example, number of subintervals n is equal to 4. I don't know. In the second example, number of subintervals n is equal to 8. ഇതുപോലെ എത്ര number of subintervals എന്നാലും ഇതേ മെത്തേഡ് ഉപയോഗിച്ചിട്ട് find value of this integral a to b f of x dx by trapezoidal rule. Next method is Simpson's rule. This is also a method to find approximate value of integral a to b f of x dx. As in the case of trapezoidal rule, we divide AB into subintervals of equal length. For this, either we are given number of subintervals n, number of subintervals n, or we are given length of subinterval. H. The relation connecting these two is H is equal to B minus A divided by N. This is the relation connecting this subinterval length H and number of subintervals N. Start with x naught is equal to A. A is the left end point of this interval. This is the lower limit of integration. X naught is equal to A. X1 is equal to x naught plus h, A plus h. X2 is equal to x naught plus 2h, A plus 2h, etc. Xn minus 1 is equal to x naught plus n minus 1 into h. This is A plus n minus 1 into h. Xn is equal to x naught plus nh. This is A plus nh. This is equal to B. So we have reached the right end point. So we stop here. Start from the left end point of interval AB or lower limit of integration. X naught is equal to A. End with the right end point of interval AB, that is the upper limit of integration B. Now, as in the case of trapezoidal rule, we find the value of the function at the end points of these subintervals x naught, x1, x2, etc. Y naught is equal to y of x naught is equal to f of x naught. Y1 is equal to y of x1 is equal to f of x1, etc. Yn minus 1 is equal to y of xn minus 1 is equal to f of xn minus 1. Yn is equal to y of xn is equal to, it is f of xn. Evaluate value of the function at these points x naught, x1, etc., xn minus 1, etc. Now, for the Simpson's rule, you have to note that for the Simpson's rule, this n must be even. For the Simpson's rule, this n, that is number of subintervals, it must be an even number. For trapezoidal rule, it must be either odd or even. Trapezoidal rule case il even or odd endu vaanengilum avam. The Simpson rule case il n oru even number avanam. Now by Simpson's rule, approximate value of integral a to b f of x dx by Simpson's rule is s is equal to h by 3 into it is y naught plus. Now this is the first term, y naught. So take y naught. Now 4 into y1, 2 into y2, 4 into y3 plus 2 into y4 plus etc. plus 2 into yn minus 2 plus 4 into yn minus 1 plus yn. This is the formula to find approximate value of integral a to b f of x dx by Simpson's rule. Y naught by n അതിനെ ഒന്നുകൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്യണ്ട. y naught by n അതുപോലെ ഇതിനെ നമ്മൾ ഒന്നുകൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്യണ്ട. ബാക്കി ഈ ഓഡ് സഫിക്സ് വരുന്നത് തന്നെ ബാക്കിയുള്ള y naught y n ഒഴികെ ബാക്കിയുള്ള ഓഡ് സഫിക്സ് വരുന്ന ടേമുകൾ 4 കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്യാം. 4y1, 4y3 എക്സെട്ര. y naught yn ഒഴികെ, അതായത് ഫസ്റ്റ് ലാസ്റ്റ് ഒഴികെ ബാക്കി വരുന്ന ഈവൺ സഫിക്സുകൾ 2 കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്യാം. ആഡ് ചെയ്യുക. മൾട്ടിപ്ലൈ ബൈ h by 3. This is the value of integral a to b f of x dx by Simpson's rules. Y naught yn we don't multiply it by any number. Excluding y naught and yn, multiply by 4 all those yi with odd suffix. Excluding y naught yn, multiply all those terms yi with 2 even suffix, 2y2, 2y4 etc. So this is the formula to find approximate value of integral a to b f of x dx by Simpson's rule. Example, use Simpson's rule with n is equal to 4 to approximate integral 0 to 1 5 x raised 4 dx. Compare with the exact value. So here integral a to b f of x dx is integral 0 to 1 5x raised 4 dx. So a is equal to 0, b is equal to 1, f of x is equal to y of x is equal to f of x is equal to 5x raised to 4. Given number of subintervals n is equal to 4, then length of subinterval h is equal to b minus a divided by n. It is 1 minus 0 divided by 4. It is 1 by 4 is equal to, it is 0.25. So length of the subinterval is 0.25, h is equal to 0.25. Now start with x naught is equal to a. It is lower limit of integration. Start with x naught is equal to a, the lower limit of integration. It is 0. x1 is equal to x naught plus h. 0 plus 0.25. It is 0.25. x2 is equal to x naught plus 2h. 0 plus 2 into 0.25. 0.5. x3 is equal to x naught plus 3h. 0 plus 3 into 0.25. It is 0.75. x4 is equal to x naught plus 4h. 0 plus 4 into 0.25 is equal to 1. So we have reached the upper limit of integration, the right end point of interval, upper limit of integration, b is equal to 1. Now we find value of the function at this point. So these points are end points of the subintervals. y naught is equal to y of x naught. It is f of x naught. It is f of 0. Find the value of the function at this x naught. X naught is equal to 0. So here the function is f of x is equal to 5x raised to 4. So f of 0 is 5 into 0 raised to 4. It is equal to 0. y1 is y of x1. It is f of x1 is 0.25. It is 5 into 0.25 raised to 4. F of x is 5x raised to 4. F of 0.25 is 5 into 0.25 raised to 4. Value is 0.0195. y2 is equal to y of x2. F of x2 is 0.5. F of 0.5 is f of x is 5x raised to 4, which is 5 into 0.5 raised to 4. It is, the value is 0.3125. y3 is equal to y of x3. It is f of 0.75. It is 5 into 0.75 raised to 4. F of x is 5x raised to 4. F of 0.75 is 5 into 0.75 raised to 4. It is 1.582. y4 is y of x4. It is f of 1. 5 into 1 raised to 4. This is equal to 5. So we have calculated the values y0, y1, y2, y3, y4. Now approximate value of integral 1 to 2, approximate value of integral 0 to 1, 5x raised to 4 dx by Simpson's rule. S is equal to, it is h by 3 into ഇവിടെ വരുന്ന ടേക്ക് y0 y4 അതുപോലെ ഒന്നുകൂടി മൾട്ടിപ്ലൈ ചെയ്യണ്ട y0 പ്ലസ് y4. Now excluding these two terms, multiply by 4 all those yi with odd suffix. Multiply by 4 all those yi with odd suffix, y1 and y3. It is 4y1 plus 4y3. Excluding y0, y4, multiply by 2 all yi with even suffixes. Excluding this y0 and y4, multiply by 2 all yi with even suffix. The only remaining even suffix is y2. It is 2y2. So in this case, this is the formula. y0, y4, keep it fixed. Remaining odd suffixes y1, y3, multiply by 4. The remaining even suffix y2, multiply it by 2, 2y2. So this is equal to 0.25 divided by 3 into y0 is 0 plus 4 into y1 is 0.0195 plus 2 into y2 is 0.3125 plus 4 into y3 is 1.582 plus y4 is 5. Calculate the value of this using a calculator. The value that we obtain is 1.0026. So this is the approximate value of integral 0 to 1 5x raised to 4 dx by Simpson's rule with n is equal to 4. Now exact value is integral 0 to 1 5x raised to 4 dx. Integral of 5x raised to 4 is x raised to 5. Limit is 0 to 1. This is equal to 1. So exact value of this integral is equal to 1. So error occurred is equal to difference between these two. It is equal to 0.0026. Error is the approximate value minus the exact value. It is 0.0026. This is the error. In the Simpson's method, we have to use n an even number. Here n is equal to 4. Next example is find approximate value of integral 1 to 3x square dx using Simpson's rule. With h is equal to 0.25. So here integral a to b f of x dx is integral 1 to 3 x square dx. So a is equal to 1, b is equal to 3, f of x is equal to x square. We have given the length of subinterval h is equal to 0.25. Length of subinterval h is equal to 0.25. H is b minus a divided by n. 0.25 is equal to 3 minus 1 divided by n. 0.25 is equal to 2 divided by n. So n is equal to 2 divided by 0.25. Is equal to a. So with this h n is equal to 8, that is number of subintervals is equal to 8. So we have to find x naught, x1, etc., x8, y naught, y1, y2, etc., y8. Now start with the x naught. X naught is equal to, x naught is the lower limit of this integral, equal to a is equal to 1. x1 is equal to x naught plus h, it is 1 plus 0.25, it is 1.25. x2 is equal to x naught plus 2h, 1 plus 2 into 0.25, it is 1.5. x3 is equal to x naught plus 3h, 1 plus 3 into 0.25, 1.75. x4 is equal to x naught plus 4h, 1 plus 4 into 0.25 is equal to 2. x5 is equal to x naught plus 5h, 1 plus 5 into 0.25 is equal to, it is 2.25. x6 is equal to x naught plus 6h, 1 plus 6 into 0.25, it is 2.5. x7 is equal to x naught plus 7h, 1 plus 7 into 0.25, 2.75. x8 is equal to x naught plus 8h, 1 plus 8 into 0.25 is equal to 1 plus 2 is equal to 3. So we have reached the upper limit of integration. B is equal to 3. x8 is equal to 3 is equal to b. This is the upper limit of integration. So we stop here. Now we find values of the function at these points x0, x1, x2, x3, etc., x8. Find values of the function at the endpoints of these subintervals. That is, now y0 is equal to y of x0. It is f of x0 is equal to 1. Now here f of x is equal to x square, f of 1 is equal to 1 square. This is equal to 1. y1 is equal to y of x1 is equal to f of 1.25 is equal to 1.25 square. This is equal to 1.5625. y2 is equal to y of x2 is equal to f of 1.5 is equal to 1.5 square. It is 2.25. y3 is equal to y of x3. It is f of 1.75. It is 1.75 square. It's equal to 3.0625. y4 is equal to y of x4 is equal to f of x4 is 2. Is equal to 2 square is equal to 4. y5 is equal to y of x5 is equal to f of 2.25 is equal to 2.25 square. This is equal to 5.0625. y6 is equal to y of x6. f of 2.5. 2.5 square is equal to 6.25. y7 is equal to y of x7. f of 2.75 is equal to 2.75 square is equal to 7.5625. y8 is equal to y of x8 is equal to f of 3 is equal to 3 square is equal to 9. So we have evaluated y0, y1, y2, etc. y8. Now approximate value of the integral 1 to 3 x square dx by Simpson's rule. S is equal to h by 3 into keep y0, the first one y0, the last one y8 fixed, multiply by 4 all yi with odd suffix, that is 4y1, 4y3, 4y5, 4y7. Multiply all yi with even suffix by 2 excluding y0, y8. So the formula is h by 3 into y0 plus 4 into y1. This is odd suffix 2 into y2, even suffix multiply by 2, 4 into y3, odd suffix multiply by 4, even suffix 2y4 plus 4y5, 4 into odd suffix, 2 into even suffix, 2 into y, 4 into odd suffix. The last term is y plus y. y0 y8 keep fixed. Multiply all y with odd suffix by 4. Excluding y0 and y8, multiply all even suffix by 2. So this is the formula. S is h by 3 into y0 plus 4y1 plus 2y2 plus 4y3 plus 2y4 plus 4y5 plus 2y6 plus 4y7 plus y8. So this is equal to h is equal to 0.25 divided by 3 into here y0 is 1 4 into y1 is 1.5625 plus 2 into 2.25 plus 4 into y3 is 3.0625 plus 2 into y4 is 4 plus 5 into y5 is 5.0625 plus 2 into y6. 2 into y6 is 6.25 plus 4 into y7. y7 is 7.5625 plus y8 is 9. h by 3 into y0 plus 4y1 plus 2y2 plus 4y3 plus 2y4 plus here it is 4, here it is 4, here it is 4. 4 into 5.0625 plus 2 into 6.25 plus 4 into 7.5625 plus 9. So find the value of this using a calculator. The value that we obtained is 8.7 8.6667. This is the value that we obtain. 8.6667. So the actual value is also integral 1 to 3 x square dx. It is x cube divided by 3. It is 1 to 3. It is 9 minus 1 by 3. This is also, so this value is also 8.6667. So up to 4 places there is no error. Up to 4 decimal places this approximate value is 8.6667, and the exact value is also 8.6. So up to 4 decimal places there is no error. Both the values are exact values and approximate value are same. ഈ രണ്ട് എക്സാമ്പിളിൽ ഫസ്റ്റ് എക്സാമ്പിൾ നമ്മൾ n is equal to 4, സബ് ഇൻ്റർവെലിൻ്റെ എണ്ണം 4 ആണ്. രണ്ടാമത്തേൽ സബ് ഇൻ്റർവെൽ എണ്ണം 8 ആണ്. സിംപ്സൺസ് റൂളിൽ സബ് ഇൻ്റർവെൽ എണ്ണം ഈവൺ ആവണം. ഇനി ഇതുപോലെ 6 n is equal to 6 ഒക്കെ ആണെങ്കിൽ വരിക. n is equal to 6 h/3 into s is equal to y0 plus 4y1 plus 2y2 plus 4y3 plus 2y4 plus 4y5 plus y6. n is equal to 6 ആണെങ്കിൽ ഇതാണ് ഫോർമുല. y0 y6 അത് അതുപോലെ വെക്കുക, ഒന്നും മൾട്ടിപ്ലൈ ചെയ്യണ്ട. പിന്നെ ബാക്കി വരുന്ന ഓഡ് സഫിക്സിനെ 4 കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്യുക, ഈവൺ സഫിക്സിനെ 2 കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്യുക. ചില ക്വസ്റ്റ്യൻ പേപ്പേഴ്സിൽ ഈ എന്നിൻ്റെ എച്ചിൻ്റെ വാല്യൂ നമുക്ക് തന്നിട്ടുണ്ടാവില്ല. ആ കേസിൽ നിങ്ങൾക്ക് ഇഷ്ടമുള്ള ഒരു എൻ എച്ച് ചൂസ് ചെയ്യാം. എൻ എച്ച് തന്നില്ലെങ്കിൽ എൻ ഈക്വൽ ടു 4 അല്ലെങ്കിൽ 6 ഒക്കെ ചൂസ് ചെയ്തിട്ട് അത് വെച്ചിട്ട് നിങ്ങൾ ഈ x0 x1 x ആണ്, y0 y ആണ്. യൂസിങ് ദ ഫോർമുല find the value of this integral to be f using a trapezoidal rule or Simpson's rule. Trapezoidal rule ആണ് ചോദിച്ചെങ്കിൽ അത് വെച്ച് ചെയ്യുക, സിംപ്സൺസ് റൂൾ ആണ് ചോദിച്ചെങ്കിൽ അത് വെച്ച് ചെയ്യുക.